All right, in this video, I want to talk about another one of the challenges. I think I hinted to this in an earlier video, which is this is it's a 2D game, yet we can walk behind things. Okay, I know that's not rocket science, right? And it's very common for games to have a backdrop, some middle, and then like a foreground. And most point-click adventure games like this, they'll generally have a background that you're in front of, and then a middle ground that you can just roam freely, and then some kind of decorative foreground to give you this illusion of depth. I don't see as often a middle ground that you can walk around and interact with. Now, why is that? Well, because that implies more 3D than 2D is, of course. So that's not hard to do. So why am I talking about it? Well, there's a trick. The trick is watch how she can. My room changed. Sorry. Watch how she can walk between. Now, how do you do that? Yeah, okay, her hair clips, forgive me, but how do you do that? Look at this. So she can walk in front of this one, in front of this one. She can walk behind this one, and behind this one. What the pooper? And yet, so it feels very, like there's like a physical object there, but it's not. It is truly just 2D assets. So how do we pull this off? Specifically, notice how she does not clip. Like if this was just a flat image, then she would, at some point, her body would pass, like let's say we did the trick of z-indexing, where this object has some kind of z-index, and here the character is behind the z-index, and then down here the character is in front of the z-index. Oh, okay, no problem, right? Well, yeah, that's actually what we're doing, but there's a trick. So the problem with this is, if we were just doing that, then at some point her z-index would appear in front of the image, right? So if the z-index of the image is, let's say it's down here, and so she's not in front of it until there, okay, how does that explain how she's still in front of it even up here? So like that, and for the chair as well. So I know I'm talking too long, but it seems like something so trivial, but it was a real pain in the butt. And the solution to that is, well, no surprise that this is not actually 2D. There's the Z layers, right? The oops, what am I doing? I didn't want to do that. So when the character moves, let me turn the camera more like sideways and see her. She's here. So as the character moves, she actually moves on the Z-axis. Oops, she actually moves on the Z-axis. That's how we get that depth, her being behind and in front of. But her movement on the Z-axis is also coordinated with her movement on the Y-axis. So, for example, if I move down, right, to give us kind of there we go, something like that. So when she moves up, she's moving up, but she's also moving forward and backwards. So moving the arrow keys up and down actually moves her in an isometric way, which we had to compute. So what we did was we kind of projected what the perspective is of this drawing, and we do this for each scene, and it's pretty easy to do. And then based on that, we know what the isometric scale is. We just computed. It's a number that's plugged into the scene, and then that number is used to translate the X and Y, the Z and Y axis movement, right? So the two move together. Okay, so that's how we get our up and down visually with the forward and back on the z-axis at the same time. Now that's also not rocket science, but it's a neat trick. Okay, the rocket science part that really isn't rocket science is we're using two images that have two different z-indexes. So when she is in front, or she needs to be behind the table when she's over here, right? So she's behind this table, but notice she's in front of that one. So she's behind this table, but then she pops in front of it. You can see if you're looking here and here, she pops out in front of it. But this table cuts off. Do you see? And it cuts off at this corner here. Now that happens because we don't want to be in behind the table anymore as the z-axis moves up. We need to be in front of it, so we're in front of this one. And that's the trick, and we do that with all these images, and it's not two drawings, it's the same image, and we just programmatically clip it at the right point based on where the anchors get placed, and it works out nice. There is an interesting caveat to this solution, and I have a better solution that is work in progress, and I want to tell you about it. So the caveat, the issue that this solution creates, and this is another reason why we don't have lighting yet, although it's coming, is because the two are at different distances, we get a distance difference in reflected lighting, and that's a no-go. So this solution has to go. Even though I'm proud of it, it was a neat trick. If we're going to use lighting, it's a no-go. All right, so what's the next solution? The next solution, which is, there's actually there's two of them that are work in progress. Let me turn off this light, it's no longer necessary. Number one is instead of having two images, this this asset, its position moves on the z-axis with relation to the character, where they are and which side they need to be in front of. So that's kind of fun and tricky because as the character moves forward, right, like when they're over here, then the desk would be moved forward, and then as they move over here, the desk would move backwards. And you might think, oh no, but that's going to be funny because it's going to move into her as she's moving left and right. Well, no, because we actually have the boundaries carefully placed such that that can't happen. So it's really nice. Now, what happens with the light is it's very subtle because the distance between these is very subtle. But also, while it doesn't look very subtle, this is in debug mode, so all the distances are exaggerated so that we can see that discrepancy much better. But in the real game, these distances are almost microscopic, and so lights don't show nearly as much of that depth difference, but it's still there. If you have a keen eye, you'll spot it. So it's not as bad as it looks. So the reason I'm saying that is because the trick where the table actually moves forward and backwards on the z-axis as she moves left and right, that causes this almost imperceptible lighting change as she moves. It really isn't perceptible, and so it gives a much smoother transition between the one side and the other because it's a infinitely stepped, smooth, like linear translation of the position of the table as she moves. So there isn't this cutoff that the light currently has. So that's hard to think of mentally, and so we're kind of not going with that. The actual route we're going to go with is instead of having, you'll see, whoop, sorry, it's like I'm flying a first-person shooter. So you'll see that there are boundaries here. If I go back into 2D mode, there is a boundary placed here that she can't walk around, and that's a 2D projection into a 3D space. So based on the 2D projection, she can't walk around it. So when we go back to 3D, what you see is it doesn't line up, and that's okay because these are just for visual. That she's actually blocked based on the 2D boundary. So I know that sounds funny. It's really hard to wrap your brain around because we're looking in 3D now, but that's, you're not supposed to look 3D. So, all right. So, but to explain what the next solution is rather than having two images where the anchor, the one is here and one is in the back, instead we have one image that sort of, let me see if I can explain this to you visually. Let's see, we want to rotate this on the y axis. So notice how it rotates, right? So what if instead, if we just rotated, if we rotated the, so if you're looking down here, you'll see if we rotate it, it looks like it's just stretching, it's just getting skewed narrower, which is weird. But up here in 3D, you can see that it's actually rotated. And so what's cool about this is as the light, well, one step at a time. I'll tell you about why we would bother to do that in a moment. First, let me just address the obvious elephant here, which is, look, now it's funny. Well, all you got to do to fix that is by whatever amount you've rotated it, right? You then have a proportional amount that you scale. That's Y. What am I doing? Scale it on X. A proportionate amount you scale it widthwise. And I'm not going to be able to do this by hand, but you get the idea. You can then scale it proportionately so that you compensate for that rotation, so that 2D it appears the same, but now you can see it's clearly tilted. So why does that matter? Well, it's because based on the Z position, you're behind it over here, but you're in front of it over here. So it works just like we want, and yet the light, actually, I did the wrong one, didn't I? I sure did. So let me hide this guy, gone, and then let me rotate this guy. You're probably already bored to tears. So rotate that guy, and then, yeah, we make it a little bit wider, right? Okay, so now as she, we'd have to move it to be into the right position that the old one was in. But now she would be able to walk. Yeah, clearly we don't have it in the right position yet. Let me see, right here, there. Okay, so now she's in front of it, and then yet she can still be behind it because, well, you get the idea. So that's the next solution, and this was a poor hack. Now you see she's clipping through it, and that's because I've rotated it too much. I was just trying to overdo it for the sake of demonstration, but you get the idea now, I think. So that's the new trick. So obviously doing this by hand for each object would be too much labor. So instead, once, like I said before, we have the perspective of the room already calculated, we then use that to do the math based on its position and its size and the depth, which we know programmatically because of the boundaries that we've set for it. Here, this little green bounding box. We can now compute what that rotation needs to be, and we bake that computation into the room, the sync button that goes right here. And viola, I know I'm saying that wrong. Yeah, so that was another challenge. And this was a challenge presented uniquely by the way we wanted our game to work. We wanted our game to be 2D artwork, but we wanted it to feel 3D-ish. I'm just resetting everything, getting rid of my changes. We want it to feel very 3D in movement and interaction, but we wanted the art style to be 2D. And so this was like a difficult, challenging kind of a problem to solve, but it was also fun, and the result is very cool. So now we can just layer things. We can see that she walks behind this, and yeah, she clips it. All right, okay. Obviously, the boundary is not right there, but yeah, that one either. Oh boy, Bad demo, bad demo. All right, I've talked long enough. So that is the one of the Z-axis 2D, 3D challenges we've had with our game. Now, in the next video, I promise, I know I've said this how many times, I'm going to stop geeking out and I'm just going to walk around.